So matrix programming uses the matrices, and it uses the mathematical operation on this matrices to efficiently do programming. Okay, and we'll see some of the simple uses of matrix programming. It's easy and it's more efficient than the general purpose programming, and we'll take a couple of examples where we'll show how efficiently you can use these features of matrix programming to do better coding, and it really helps handling data, and it allows us to use a number of mathematical functions which makes our life easy while handling data. So the first thing is, what is a matrix? Many of you must have heard about it, must have also learned it in school and colleges. Just to do a recap of what is matrix, and what are the operation that can be done on matrices. I'll just start with the basic concept first. So a matrix is nothing but an array of numbers or symbols or expressions. Most of the times you will get numbers, but yes, you can also have symbols and expressions as well. And we can actually keep the data which we call variables in the analytics or data science industries in the matrix form and do the operation on them. So which is a special case, and it really easy when you do the operation on these variables by putting them in a matrix form. So what is a matrix? The example of matrix is like this. Say for example, salary. We are keeping salary of employees, and we keep it in an array form where we separate the salaries of employees by a space or a comma, and we store it in this form. So that becomes a matrix, right? And matrix could be of different dimensions. Like in this case, we have only one row and 4 columns, so it's a 1:4 matrix, right? So we can have a 2:2 matrix, something like this, 5, 10, 15, 20. So this is a 2x2 matrix, 2 rows and 2 columns. We can so this is a rectangular square matrix. This is a square matrix because both rows and column are same. We can also have not non-equal rows and columns in the matrix. So we can have something like this. So we have got 3 rows and 2 columns, right? So so this is a 3 by 2 matrix, right? So that's about matrix. We can do a lot of mathematical operation on the matrix. First thing is that we can add scalar to the matrix, and it gets added to all the numbers. We'll take this one, 5, 10, 15, 20. So let's say this is matrix A, and if we want to add a number, right, we want to add a number 1 to all the elements of matrix A. So what will happen? It will become 6, 11, 16, 21, right? So when we add a scalar, so we call this a scalar because this is just one number, and we call that mathematically, we call it a scalar. So when we add a scalar to the matrix, it gets added to all the elements of the matrix. So it gets added to 5, 10, 15 and 20, right? So we get a new matrix, right? Similarly, we can also multiply a number or a scalar to a matrix. Say we want to multiply A multiplied to 2. So 2 is a scalar and A is a matrix, and we are multiplying. So what will be the result? 10, 20, 30, 40, right? So 2 gets multiplied to all the elements of the matrix A. Similarly, we can subtract and we can also divide, and it gets divided or subtracted with all the elements present in this matrix. So that's the beautiful nature of matrix, so that within one operation we can actually act upon all the elements of the matrix. So that's the beauty of using matrix for handling your data. So how does it really matter to doing an analytics related work? Well, in analytics we get data in the form of we get data from Excel sheet, we get data from mostly the relational databases where we have columns and we have so many rows. So we can put these variables or the data into matrix form and do the operation on them, and get back to the original data form after doing the operations. So that makes the data handling very easy. Okay, so we'll do a mathematical operation on this, and I'll use the programming language R. There are so many programming languages which has got the metrics. Most of the programming languages, whether it's C, whether it's Java, whether it's MATLAB, even SAS. SAS has got SAS IML, which can handle metrics. So here is a simple example. Here is a vector, which is the simplest form of a matrix. It's a one-dimensional vector, one-dimensional matrix, and this is how we define. And then we're trying to multiply. Just use a multiplication sign, cross, and it gets multiplied to all the elements. Similarly, you can subtract. I'm subtracting a number 50, and it gets subtracted from all the elements from this matrix. We can also add two matrices, but the two matrices should have same dimension. Like in this case, it's 1:4. This is called a salary matrix, and then there is another matrix called bonus, which is also a 1:4. So the matrices should have same dimension so that we can add. But scalar can be added to any matrix. That's not an issue. So you get what is known as net salary, so which is sum of these two matrices, right? So if it's like it's one variable and this is another variable, so salary is one variable, bonus is another variable, we can get the third variable by adding these two. So that's related to the normal data handling work that we use in analytics projects. Then we can also have easy access to data points. So we may have a very large data and we just want to access or do operation on one particular data point or a fixed set of data points, right? So how do we reach out to that? In normal programming languages we can use the array, but matrix also gives you the same flexibility and additional flexibility to that, to what you get in the array format in normal programming languages. So we are defining a matrix here. So the proper way of defining a matrix is using the matrix function in R. And say for example this is the matrix. We have got 4 elements, 2, 3, 4, 5, and then we are using the keyword n row. So n row is 2, that means we are going to have 2 rows, and we're also going to have 2 columns, so n column is also 2. And then we also use by row 2, that means the matrix will be filled by row, so it go row by row, right, and gets filled, the numbers are going to be filled. So so this matrix A, which we have defined above, is going to have 2, 3, 4, 5 arranged in this way, 2 rows and 2 columns, and you can change the rows and columns to make it a square matrix or a rectangular matrix, right? So that's the way you define a matrix in R. So another example, this is a little bigger. We have got 9 elements and now we have 3 columns and 3 rows, and now you can see we've got a 3 cross 3 matrix A. Say for example I want the first row and the second column element. So this is the one, right? 300. It comes to the first row, and the second column, right? So that number I want to access. I want to see what number is that. So how do? You just index it. So index is first row and second column, right? You put it in the matrix. So it's matrix and within bracket 1 comma 2. So that is the index through which it is going to identify what is the number in that particular index or that particular address, right? So it gives 300 to us, right? We can also do operation on that. Say for example, we want to assign the same variable and add it, like adds a number to it, only to that particular element. We can also use the index and add a number, and it's going to change. Okay, we can also take the entire column and the entire row, right? Say for example, we want the entire column, the first column of this matrix, okay, this one. So how do we do that? We keep the row part null. We did keep it blank, and we put a comma, and then we use first one, right? That means we only indicate the first column, okay? And then you actually get the first the elements of the first column. So 200, 500 and 306 comes out in the result, right? Say for example, we want the first row. So first row is this one, right? So we want that in the result. So we just reverse it. Instead of using the column as 1, we just use the row as 1 and keep the column blank. Now you get all the elements from the first row, right? So similarly, you can get a particular column, particular row, or a subset of the column. That's also possible by doing some sort of adjustment to this code. That's the way you do. We can get multiple rows, multiple columns. That's also possible. So here is the example. See, we have the matrix A, and we keep we want the first column and third column, right? So we keep the row blank, and we define a subset matrix within this matrix, and we say that only we want 1 and 3, right? And we get only the first column and the third column in the result data set. And we can assign it to another matrix and name it differently also. We can just say this is equal to B, something like that, and we get to a different matrix, right? So these are the basic operation that can be done on the matrices. Let's learn more operations. So one operation is known as inverse, and there is also combine that can also be very useful. So inverse is nothing but changing the rows into columns and columns to rows, right? We use the function t in R to do the transpose. Okay, so this is not inverse, this is transpose. Inverse is different, and we're not going to learn what is inverse. That's more complicated. So this is transpose, not inverse. They're different. Okay, so this is wrong. Transpose. So how do you do a transpose? Transpose is changing rows into columns and columns into row. Okay, so pardon me, I used inverse in the beginning. That's wrong. So now we have seen what is A. When you take a transpose of A, you will see that the rows numbers, so 200, 500 and 306 used to be the first column. Now it has become the first row, right? And 200, 300, 400, this one used to be the first row. Now it has become the first column. So it has changed. Okay, now we define two matrices. Matrix A, we already have matrix A, and now we take the transpose of A and we define it as or we assign it to another matrix called B. Now we have two matrices A and B, and we want to combine, right? So we can combine in two ways. We can combine in the row wise, in the column wise. Okay, so when we do a column wise combination of two matrices, it will get assigned to the right hand side of the matrix, right? And when we do a column wise, it gets assigned to the down, right? So there is no additional column, it just there will be 3 more rows. Similarly, if you are doing column wise, there will be 3 additional columns. Okay, no additional rows. The first one is the function cbind can be used to have additional columns. So we're combining A and B, so B get appended in the right hand side. So if you have some appending work to be done, we can use this function cbind. If we want to append down below, we want to append in the rows, we can have additional rows, same number of columns, so it gets appended down, right? So you see the matrix get appended down the matrix A. Okay, the next is matrix multiplication. Matrix has got two types of multiplication. One is the simple multiplication, where it is multiplied number wise, direct element wise multiplication. So the element wise multiplication is nothing but, say we have matrix 1 2 and then B 2 3. So when you do element wise multiplication, which is simple multiplication, you just multiply the corresponding number. So it gives 1 to multiply to 2 and then 2 multiply to 3, which is 2 and 6. Okay, so this is element wise multiplication, is simple multiplication, but matrix multiplication as such is little more complicated. So there are some rules to be followed. The first thing is that say we have got two matrices, 1 and 2, and then there is a matrix B, so I got 2 and 3. The index of the dimension of this matrix A is 1:2, and this is 2 cross 1, right? So the number of columns in the first matrix would be equal to the number of rows in the second matrix. Only then these two matrices can be multiplied, otherwise not, right? So the resulting matrix will have the index 1 cross 1. So the left hand part and the right hand part of the two matrix, and you will get a matrix of 1 cross 1, right? So when we multiply, so how do you get multiplied? So you get 1 cross 2 and then 2 multiplied to 3, so 2 cross 3, sorry, 1 cross 2 plus 2 multiplied to 3, so we get 2 plus 6 which is 8. So this is the final matrix. So when you multiply A and B, which is the actual matrix multiplication, not the simple element multiplication, you get the value as 8. So in R, you can do a simple multiplication by taking the simple cross, but if you are doing the matrix multiplication, ensure that this rule is not violated. The number of columns and the number of rows, the two should be matching. Now we have taken an example. We got 3 elements in this case, so it's a 1 cross 3 matrix, and we have another matrix B with a 3 cross A matrix. So when we do a multiplication of that, so 20 multiplied 25 plus 30 multiplied to 35, and then 40 gets multiplied to 45. When you sum it across, you get 3,000 and 350. So this is the sum of the multiplication, or sum product, right? So this is the sum product of number. Sum product is something that we often require to compute in a lot of cases. So a simple matrix multiplication. Otherwise, one has to write a for loop. In the normal programming languages, you write a do loop or a for loop. Take two indexes I, j, and then you multiply. It takes a lot of time, uses a lot of computing power. Whereas here, you just use two matrices and do multiplication. The computation is much easier, and you can just do the operation on all the elements in just in one go. You don't have to do the looping, which gets the iteration gets repeated over a time, which takes a lot more time for large data sets. The last one is how do you reshape data. Okay, so you can reshape the data in just one step. I'm taking an example here. So this is a matrix of 1 to 20. I'm using the sequence function to create this matrix. So a number is the matrix, and we've got numbers from 1 to 20, right? I want this 1 cross 20 dimension matrix to be of you know um, 10 columns and 2 rows, right? So I reshape the matrix with the function matrix, and then use number as the input matrix, which I have defined in the previous step, and then making into 2 steps, right? So I use this function 2, this number 2 here, which says that there has to be 2 rows in this case, right? Or so it gives me a reshaped version of the matrix number. We can also define how many rows and how many columns are to be there, right? So ensure that all the numbers gets accommodated in the rows. So I've used two rows and 4 columns. Now using 2 rows and 4 columns, you cannot have all the 20 numbers. Maximum you can have is 8 numbers. So you can make it like 10 or 4 5. You can have 4:5 matrix, or a 10:2 matrix, or 2:10 2 cross 10 matrix, and you can reshape this matrix into different forms in just one go, right? It's very useful in handling data when you replace when you try to modify the data into some form. Just one command and it gets modified very easily, right? So when you have perfect control over each and every data point, you can also do a lot of things, like you can replace the missing values or change some of the values by using this very powerful function and using the indexes. Okay, one more operation. The last one is how to find out the diagonals of an element. So diagonals is nothing but with the same index, right? Like 1 1 2 2 and so on, right? The row number and column number has to be same. So this is the diagonal number. Diagonal numbers are this one. So how do we find out get the diagonal numbers? This is important in many cases. So use this function diag, and you will get all the diagonal numbers in a separate matrix. We can also use to find out what is known as an identity matrix. So, and this is very useful a lot of times for data manipulation. So we want only the diagonal elements to be populated. So the identity matrix always has the diagonal elements as 1, and all the rest elements are all 0. And we can multiply this identity matrix into scalars and come up with different forms of matrices, and that's useful in many cases while doing operation on our data, where we want only the diagonal matrix to be diagonal numbers to be populated, and rest all numbers to be 0.